Hi, everyone. I'm not sure how many of you live in a hilly city like San Francisco. Speaking for myself, I have lived in SF for the past 3 years. But even to this day, I still run into this issue where every time I try to get from point A to point B in the city, whether it's for dinner, for a walk, I'll look at Google Maps and be like, that looks easy. But when I actually get on my way, at some point, I'll realize that up ahead is a hill with a non-trivial incline. And that happens a lot in San Francisco because it is so hilly almost everywhere. When I think about it, this sort of uphill journey resembles Airbnb's journey to service-oriented architecture, or SOA for short, in the sense that we started out in a flat and straightforward path of migrating to SOA, then realized that there's an even steeper and much more interesting learning curve beyond that. Today, I will share with you 4 key lessons that we have learned from our journey along the way. But before that, let me introduce myself. My name is Selina, and I'm a software engineer at Airbnb. A fun fact about me, my favorite Slack channel at work is the Dad Jokes channel, where people share dad jokes. On most days, I'll be reading other people's jokes, but on the occasional day when I feel inspired, I will post some as well. And here's one for you. Why did a scarecrow get a promotion? It is because he was outstanding in his field. Haha. It's weird that I don't get to see people's reactions live because this is a pre-recording and I'm basically talking to a wall. But anyway, now that I have gotten my bad dad joke out of the way, here's the 4 lessons from our journey to SOA. Let's dive straight into the first one. Invest in common infrastructure early in your SOA journey, because this will help to turbocharge your migration from a monolith to SOA. To give you more context, let's spend some time first on how we went about our migration. Back in 2008, just like most small scrappy startups, Airbnb started out with a single web application written using the Ruby on Rails framework with the model view controller paradigm. But over the years, as Airbnb expanded its global footprint, product offering, and engineering team, the single web app you saw here grew into a massive monolith. And since it is developed using the Ruby on Rails framework, internally we call it the monorail. As more engineers jump onto the monorail, it was becoming slow, unstable, hard to maintain, and a single source of failure. So in 2018, we launched a company-wide initiative to migrate our tech stack from this slow-moving monorail into a service-oriented architecture. Similar to the model view controller paradigm, we decided to decompose the monolith into presentation services that renders data in a user-friendly format for front-end clients to consume, as well as mid-tier services that's grouped around shared business concerns and can be used in multiple contexts. And then under those, there are data services that encapsulate multiple databases in a uniform data layer. To make this abstract diagram a little bit more concrete, let's use host reservation details, or HRD for short, as a case study. Before I explain what HRD is, I want you to meet Maria. So Maria is a new Airbnb host based in Colombia. She just published her listing on Airbnb last week, and today she's received her first booking request. When she opens her host inbox, she sees a message from the guest, Christopher, and this panel on the right here that displays key information about the trip being requested and the guest is the host reservation details panel. And it pulls a lot of information from a myriad of sources in our system, including users, payments, listings, reviews, and etc. In fact, there's a lot more information that it offers even below the fold. So to migrate this complex product feature into our SOA paradigm, we basically broke down the logic into a presentation service that handles the view layer business logic, a few mid-tier services that handles ride operations such as confirming or declining a booking request, and some data services behind them down the stack that encapsulate different product entities such as reservations, users, and listings. And of course, there are other services on each layer, and we interact with many of them every time we serve a request. And by the way, let's call our reservation presentation service ramen, because who doesn't like ramen? So what makes this monumental task of migrating complex product logic possible are the common building blocks that our infrastructure team provided that allowed us to build services with confidence and speed. First, we have an in-house API framework built on Thrift. It is used by all Airbnb services to define clean API and to talk to each other. So let's say that as part of the business logic, Ramen has to read data from Tofu service. The Tofu engineer only has to define the endpoint in simple Thrift language, and the framework will create multi-threaded RPC clients to facilitate inter-service communication and handle stuff like error propagation, observability metrics, and schema validation. This means that engineers can focus on implementing the core business logic and not spend time worrying about the plumbing details of inter-service communication. Based on this framework, we have also developed productivity tools such as this API Explorer, which engineers can use to browse different services, figure out which endpoints to call, and how to call them. Second, we also have PowerGrid, which is another in-house library built here that makes it easy to run tasks in parallel. Under the hood, PowerGrid helps us organize our code as a directed acyclic graph, where each node is a function or a task. We can use it to model each service endpoint as a data flow with requests as the input and response as the output of the data flow. Because it handles multi-threading and concurrency, we can schedule tasks to run in parallel. So let's take host sending a special offer to the guest as an example. There's a bunch of checks and validations that have to be performed before we allow the host to send a special offer. So using PowerGrid, we will take the listing ID from the request and use it to fetch information about the listing from the listing data service. Then we will pass the information along to a bunch of downstream services for validation, which happens in parallel. After that, we will aggregate all validation responses, make sure that we got green light from everyone before writing back to the special offer data service to send it to the guest. So using this library provides a few benefits. First, it provides low latency for performing network I/O operations concurrently, which really makes a difference when your endpoint has multiple downstream dependencies. It also offers granular metrics for each node in the data flow, which helps us to pinpoint any bottleneck in the data flow pipeline. These benefits help to ensure that our service is performant and observable. The third building block that we have is OneTouch, which is another framework built on top of Kubernetes that allows us to manage our services transparently and to deploy to different environments efficiently. So this framework has two key aspects. First is that all service configurations should be managed in one place in Git. So for example, all the configs for the ramen service lives in this infrastructure folder. From there, we can easily configure dependencies, alerts, logging, deploy environments, CPU resources here, right alongside our source code folder. And then second, we also have this magical K tool, which is a command line tool built on top of Kubernetes that allows us to deploy our service to different environments on Kubernetes clusters. So if I just type KAll on the command line, it will automatically generate the configs, build the app, and deploy it to a remote cluster. If you think about it, it's just like making a bowl of ramen, where first you have to generate the bowl, the configs, and then build the ramen, which is the main app, and basically deploy with the garnish with your last step, which gives you the final end product. So all environments, whether it's staging or production, are deployed the same way. In this way, from the service governance perspective, it makes it very easy for everyone to orchestrate, deploy, and diagnose a service because there's only one place to look and one place to learn. Lastly, we have Spinnaker, which is an open source continuous delivery platform that we use to deploy our services. It provides safe and repeatable workflows for deploying changes to production. And one aspect that has been especially helpful for us is the automated canary analysis. In this step in the deploy pipeline, we basically deploy both our old and new snapshots to two temporary environments respectively. Here we have baseline environment and canary environment, which has the new snapshot. And then we route a small percentage of our traffic to both of them. Then key metrics such as error rates are automatically ingested and fed into statistical tests that produce an aggregate score for the new canary environment as measured against the baseline. Then based on the score, the analysis tool will decide whether to fail or promote the canary to the next stage in the deploy pipeline. So in a service-oriented architecture where so many services are deployed every single day, this helps us to release code changes at scale with confidence. So thanks to all these infra pieces, we were able to migrate our core product functionality to SOA in the span of just 2 to 3 years and reap the benefit of higher reliability, business agility, and loose coupling between our services. So after all this work, you think that we can now finally take a nap in front of the computer. But honestly, we are not done. In fact, we haven't started climbing the metaphorical hill. What we realize is that sometimes it could take more time to ship a feature due to new frictions introduced by SOA, since now engineers need to acquaint themselves with more services and make changes in those services before they can ship a change. What's more, due to unconstrained call patterns between services, where anyone can call anyone, our dependency graph ended up being a little bit complicated and start to look something like this bunch of Christmas lights. This is unideal and potentially dangerous, especially when there are circular dependencies between our services, which can make it really hard to visualize and understand the intricate relationships between our services. Basically, it's a complex mental model that engineers have to maintain. Also, highly stable services can be easily brought out by more volatile services because it's an ecosystem where everyone depends on everyone else. So to address these issues, we decide to simplify service dependencies. If you recall, we designed our architecture to be a tiered tech stack consisting of presentation, mid-tier, and data services. And the motivation was to separate services into layers as shown in this diagram based on their technical priorities. Basically, as we go up the stack towards applications and UI layers, the primary consideration is iteration speed and schema flexibility, leading to more specific and fast changing API. And this generally maps to our presentation services. On the other hand, if we go down the stack towards platform and infra layers, since their blast radius is bigger, they need to have more generalized API and schema and higher reliability and stability requirements. So for an SOA to be reliable and resilient, it is imperative that stable services do not depend on more volatile ones. So conceptually, a higher tier can call a lower tier service, but not vice versa. However, the problem with our existing SOA system was that there was not enough service governance and dependency management to enforce this fundamental principle and to restrict who can call who. Hence, to enforce a topology-driven layer architecture, we introduced service blocks at the platform layer, where each block is a collection of services with related business functionalities. For example, the listing block here will encapsulate both the data and business logic that inform core listing attributes. And then it will expose a simple, consistent read and write API to upstream clients through the facade. So under the hood, the listing facade will orchestrate coordination between the underlying data and business logic services, while providing a layer of abstraction and concealing the underlying complexity from upstream clients. We also enforce a strict topology by prohibiting clients from calling any internal services, as well as prohibiting blocks from having circular dependency with each other. So with such a higher level of abstraction, it is much easier for upstream clients to discover and leverage core functionality. It is also much easier for us to manage block dependencies and maintain high levels of reliability. Next, we also spent some time on platformizing data hydration. So looking at this diagram again, we have noticed that we have quite a number of presentation services. If we zoom into a typical presentation service, They are usually performing three main functions across the board, which include first, fetching and hydrating data from different downstream services. For example, ramen service alone calls 10 services to hydrate data for host reservation details. Second, these presentation services also perform simple transformation of the data. For example, ramen service can easily have to merge data from 10 different services into something that the client expects. Third, services can also perform permission checks before proceeding with more complex business logic. As time went on, what we realized is that engineers were spending a lot of time on these three functions, even though it is a lot of duplication, boilerplate code, and repeated patterns. So our approach to this problem is to introduce a platformized data access layer that provides a single consolidated GraphQL schema, stitching together different entities such as listings, user, reservations across all of Airbnb's online data. It also serves as a platform to host all the mundane data fetching and hydration logic, rather than requiring duplication of this logic across many different presentation services. So together with the more complex presentation logic on the right and the right logic on the left and right logic on the right, both of which attend to a different set of constraints and the detail of which we will ignore for now, this data access layer will eventually replace all presentation services. The service blocks below the data access layer will also replace the old data services as well as mid-tier services. So you can see that with this data access layer, we continue to simplify service dependencies. But going back to the layer itself, in essence, it is an enhanced GraphQL engine that reimagines the way data is fetched in our SOA by going from a service-oriented to a data-oriented hydration paradigm. So, for example, instead of writing code to explicitly call reservation data service to get reservation data, the caller will instead write a declarative query on the reservation entity. And then they can even fetch associated listing and guest user data. So such queries are made possible by a GraphQL schema that's enriched with special annotations that we built in-house. For example, on the screen, you can see that the service-backed node annotation with its templated fields allows us to associate a GraphQL type with a service endpoint, where the response from the service will be automatically wired back to corresponding attributes defined in the GraphQL type. As another example, the service-backed node key annotation allows us to link different types together. For instance, the guest ID on the reservation type can link to the fully fleshed user type. This allows callers to basically fetch user fields alongside the reservation fields in one query. Aside from these, there is also a privacy annotation that wires in permission checks, and also an ownership annotation at the top that makes it easy to route alerts to the right teams. So all in all, these annotations with declarative templates allows us to easily create types, construct an entire graph, and code gen the data loaders for each type in a way that is configuration driven, which reduces the potential for error. In addition, we also have this online IDE built on top of the open source GraphQL library that makes it easy to explore the schema and inspect the data fetched. So to summarize, platformizing data hydration allows engineers to focus on product innovation instead of writing the same data hydration code over and over again. Lastly, as we continue to evolve our SOA, we also decided to unify our client-facing API. In our original SOA diagram, each presentation service is usually maintained by different product teams by virtue of Conway's law. An implication of this is that each presentation service tends to define their own client-facing API and solve problems their own way. There wasn't a common set of best practices, and people sometimes ended up reinventing the wheel. The result is lower developer velocity, more bugs, and sometimes inconsistent user experience. So our solution to the problem is App Framework, which is an in-house, unified, opinionated, service-driven UI system. To quickly visualize how it works, this is what the user sees on host reservation details. And this is what our app framework sees, where everything on the page is broken down into a standardized section. The content and styling of the UI within each section are driven by the backend. This leaves the front end with a thin layer of logic that's responsible for just rendering these sections. In this diagram, you can see that on the presentation backend, we expose a common schema to the clients. And you can see that each of the front-end clients has an app framework runtime that is responsible for interpreting API responses from the backend and rendering it into UI for the user. Taking a deeper look into the standardized API response, you can see that it's broken down into two parts. First is the registry of all the sections needed for a page. And then second, we have the screen structure, which expresses the layout of the sections on the page. For example, this part can dictate that the header section should go at the top of the page and the card section should go right below it. And zooming further into each of the sections, here's the schema definition with a concrete example on the right. So focusing just on the key attributes, we have section data, which represents the data model itself. For example, here we have a list of user info, including where the user lives. And then we have the UI component type, which refers to the UI component that will be using this data from the data model to render the UI on the front end. In this case, we want to render the list as the list data as a bulleted list. One thing to call out here is that it is possible for one section data type to be rendered by a different UI, by a multitude of different UI component types, which affords us flexibility and variation in product UI. And more importantly, all these sections should be totally reusable across different services. For example, a user highlight section can be shared between guest-facing and host-facing services. There are also a few other key features of the app framework. First, we have support for different layouts and placements of sections on the page, which provides flexibility and range for product design needs. Second, with deferred sections, we can delay the loading of more expensive and sometimes slower sections to a second network request, which helps to improve our initial page load time and overall user experience. This is especially helpful for mobile clients that can sometimes have weaker internet signals and takes longer time to load data between requests. Lastly, the framework also logs impression and UI actions on each section automatically, which is really helpful for measuring user engagement when we launch a new feature through app framework. And to make the developer experience easier, we also built out a web tool that allows engineers to easily visualize their API response in real time by copy-pasting the payload into this tool. So in summary, within app framework, we got to isolate a robust, commonly shared schema foundation, as well as rendering components, layouts, and tooling, which are designed to evolve slowly under strict scrutiny. This separates the tooling, the infra tooling, from more volatile product code that changes from day to day. Second, app framework also empowers product teams to execute fast with flexibility by providing clear patterns for reusability and customization. For example, using pre-built sections, product teams can easily launch new features across clients without any mobile app versioning or deploys on a mobile front end. Lastly, app framework also helps to ensure consistent user experience and maintain product quality by consolidating presentation logic that used to be scattered across all three front-end platforms into one backend. So in conclusion, we have gone through a lot of material, and now to recap all the lessons we have covered so far. First, invest in common infrastructure early to turbocharge your initial SOA migration. Second, as you continue to expand and scale your architecture, prioritize simplifying your service dependencies for long-term stability. Third, platformize and abstract common patterns such as data hydration so that product engineers can focus on solving new and important problems. Lastly, unify client-facing API into a robust system of reusable parts and safeguard rails to support fast product iteration and to launch features with confidence. So one overarching theme in the progression of these takeaways is that we continue to streamline and fine-tune our layers of abstraction based on the way we work and the way we build our products, starting from the infra layer to platform layer with the service blocks, then to application and UI layers with app framework and whatnot. What informed these stepwise improvements were the common pain points experienced by engineers and end users. So it is true that sometimes it means that we have to undo some of our earlier work, but that is fine. It is hard to get everything right the first time. The point is to keep evolving the architecture to improve developer velocity and to serve prevailing business needs. So going back to the metaphorical hill in SF, when we set out to migrate to SOA, we were not expecting our path to include this steep hill up ahead. But the lessons along the way were rich, and the learning curve was in fact quite an exciting and fulfilling ride. We can't say for sure that we have made it to the top of the hill, but when we survey our current tech stack, we begin to see that SOA is not a fixed destination. Instead, like a real city, it is constantly changing and evolving into something more resilient and lasting. Thank you.
Yeah, that was a super, super interesting presentation. Thanks for doing it. So one thing I really have to ask is why SOA and not microservices?
Oh, I guess in our mind, we were just trying to break down our logic into components, but we didn't necessarily want to break it down so that everything is like, just focus on one small task. So I think in general, we try to, I guess, not use microservices because that might, some people might think that, oh, we can, for every small business feature we have, we will spin up a new service for that. As it is, we already have a lot of services, so we are trying to prevent like this.
Well, yeah. I mean, there's a lot of interesting debate around how micro is micro, right?
Right.
Which you touch on an interesting question, which is like, how granular are your services? So sort of like, I don't know, the ratio team number of developers versus number of services, or number of teams versus number of services. Do you have any kind of ratio there?
I would say we probably right now, every team has like at least 2 to 3 services. But as we have evolved, we are in general moving towards consolidating some of these logic, because what we are finding is that there's a lot of overhead in maintaining a service, just in terms of stuff like SLOs, like performance guarantees and test levels and stuff like that.
Yeah. So, yeah. I mean, interesting. That's like a common pattern I've seen working with clients, where it's, like there's this tendency to build fine-grained services almost as much as like one service per developer. And then it's like, why? And then kind of, why not just consolidate? Because unless you have a very good reason to, have more per team.
Yeah, and I think at some point it becomes a single point of failure per service too, when you just have one developer who knows all the context to that service. Because when it comes to on-call, it's really hard to, like just have a sustainable load for engineers when they have to like cover different services that they are not familiar with. So that's also one aspect of operation where we are trying to just like slim down.
Yeah.
Consolidate.
Yeah, definitely. The other interesting thing is sort of the conventional wisdom around microservices, or we could say SOA, is sort of kind of a vertical vertical slices around business domains. Yet sort of one distinctive characteristic of your architecture is horizontal technical slices. At least Am I right in thinking is that maybe the technical that horizontal division was your initial thought back in 2018, but now with this block concept, you appear to be, they seem to be more like business domains. So
that's kind of interesting, because in my mind, it's more of going from vertical, where in the past each vertical will have one presentation service, a derived data, and then like a data service at the bottom. But then now now we are trying to consolidate, like, for example, like the presentation layer in one horizontal chunk, and then maybe towards the bottom of the stack we have like different block facades, but those are also using a standardized API framework like GraphQL gateway layer. So in a way, I think we are trying to reduce the level of duplication and just repeated patterns in each of the layers by trying to make it more consistent. Yeah.
So there was a question. What was the question about? Yeah, sort of, I guess you could say reliable. How do you achieve reliable communication? Because it sounds like and maybe this is by consolidating services, but there seems to be a bunch of, thrift-based synchronous calls, right? Which, so that's kind of, that's synchronous coupling essentially. And how do you manage to still be available, highly available, as Airbnb obviously is?
Yeah, so that's a complicated issue. I think over time we have resorted to a bunch of procedural and as well as like technical measures. So like just in terms of processes, we now require every service to have to define their own SLOs. Basically performance guarantees on how fast their API should be, what's the error rate, and to have weekly check-ins at a higher team level to make sure that all the services that the team owns are performant according to their standard. And then we also have test level requirements. All these are like part of our commitment to craft initiative, where we are trying to make sure that each of these services have a bare minimum of service quality. And in terms of technical solutions, we in our service IDL framework, we also have aspects that prevent just retry storms, where if a service is unresponsive, upstream might just retry multiple times, and that might cause the service to degrade even further. So we have ways to have a circuit breaker that prevents stuff from escalating into a catastrophe, basically. So those are a few things that we have tried, and I think it's a constantly I guess the ecosystem itself is very it is changing from day to day, just from new product development. So I feel like that's also one aspect of maintaining the service. We have to be keeping a close eye on a lot of these services, especially the more fundamental ones, the facades and the data services at the bottom.
Yeah. Okay, what was that? I was looking at my list. Sort of, so you migrated to services. How did it help? Because originally, apparently, it was you sort of in monolithic hell back in 2018, and so are you now in SOA Nirvana now?
No. So I think it was just the hike across SF, where you're just we're still trying to, I guess, scale the learning curve, but not quite there yet. I think it is very interesting, especially with the evolving business requirements with Airbnb. I guess we are always so initially I think it was very simple in our mental model, where we're just trying to break down this big chunk into smaller chunks, and that is service oriented. But now I think we are trying to think at levels of abstraction that kind of maps to our product, but at the same time is technically sound. So that's why we have like data access layer, where everything is represented as, the different parts of our data constellation, instead of, thinking of things as services. So in those endeavors, I think that's where things get really interesting and kind of complicated, because products can be anything. There's no like very hard definition of what a product feature is. It can be a user, or it can be some user feature that is kind of abstract. So I feel like trying to navigate that as a team is something that has been sparking very interesting conversations, like how we want to organize our data schema, and how we want to map that to the underlying services. So like that process of like mapping from how we represent our product to how we build our services has been just like an ongoing conversation across different teams.
Well, I think building complicated software is challenging, right? No matter what your architecture is. There's just a question in the chat about what patterns did you apply in the data access layer to improve performance?
I would say it really differs from entity to entity. I would say, in the data access layer. So we do have stuff like caching, where in a request, GraphQL request, there might be different parts of the query that ends up hitting the same service. So in a way, we'll cache the exact request that we know will be idempotent. We'll get an idempotent response back. And then sometimes we also batch requests into a single service, single request to the downstream service, stuff like that. Yeah, there's a lot of underlying logic that the team behind the unified data layer builds that other engineers don't have to worry about.
Yeah. Another question I was going to ask was, presumably this migration to SOA actually like improved how you work, though, right? Never mind it's still challenging, but it improved deployment frequency and reliability, and it made a big difference, right?
Yeah, I think it did. Because initially it was just one deploy train on this one monolith. So everything else will be blocked if you just have this one failure in one of the APIs. But right now, I think it's also because we have separated out the presentation layer from the bottom layers. Presentation layer tend to evolve much faster. So if things break there, I would say tend not to affect the more like fundamental and services with bigger blast radius.
Oh, cool. Well, I think that's it. Thank you so much for the presentation. And there is a hallway discussion following this.
Yeah, I'll be sure to join that.
Yeah, thanks.
Cool. Thanks, everyone. Thanks, Chris.